Okay, this is lesson 5.8. It deals with coordinate proofs. We are going to do one thing. We're going to place figures in a convenient location on the coordinate plane. That would make it easy to do these coordinate proofs. And then the second thing is you would write coordinate proofs. You are going to see that Mrs. Lenz really cut the lesson down to about 10 problems. Very difficult lesson to teach outside of school, so I'm going to do my best. When I say a convenient location in the coordinate plane, okay, coordinate plane, I want to place a figure in this plane that would be the most convenient to do a coordinate proof. Now, what I'm talking about a coordinate proof is you're trying to prove things, okay? Maybe trying to prove that some lengths are equal. Well, if lengths are equal, you guys know how to find length. And that would be with the distance formula. You had to do that a little bit in yesterday's lesson, getting ready for today. Okay, another common formula, let's go back to Unit 1, would be maybe a midpoint formula. And if you guys remember the midpoint formula, we're finding the middle points. So it was actually the average of the x's and the average of the y's. And because it's an ordered pair, we're going to put the parentheses around it. Okay, back to a convenient location in the coordinate plane. So, for example, if I wanted you guys to place a square in the coordinate plane, if you guys pop this square up here, and let's just say you were like at 10, 12, and let's say it's a square with side length 4, then this would be 14, 12. And this would be 10, 16. And this would be 14, 16. Okay, you look at the numbers there. And we have used a 10. We have used a 12. We have used a 14. And we have used a 16. So you have 4 different numbers. Okay, so let me erase that. If you were to place that square in the corner using 0, 0 as one of its coordinates, same size square, side length 4, you would have 0, 0, 4, 0, 0, 4, and 4, 4. Lo and behold, you've used obviously 0, but then you've used the number 4 for all 4 of these coordinates. Okay, now what makes a convenient location in the coordinate plane is a couple things. We try to stay positive, as in mathematically positive. So what do I mean? Usually in quadrant 1. Okay, so quadrant 1 gives us positive ordered pairs. Okay, the more zeros you can get, the better it is, because you got to find some distances. Okay, so for example, if you're placing a triangle, okay, convenient location would be to obviously use the origin and then maybe place the triangle here. So you could also have something 0 as its coordinate. Okay, so what we're trying to do in this lesson, let's wrap it up. What we're trying to do is place figures in a convenient location. Okay, and the reason is it stays in the positive quadrant, okay, which is quadrant 1, so right here, and we try to use as few variables as possible. Okay, so for example, if I was talking about a square, 0, 0, A0, 0A, and AA. Now before I did 4, 0, 0, 4, and 4, 4. Okay, but I'm just picking a variable, so that would be a very convenient location. Okay, when you're trying to prove these, what I really would like you to get out of this, and I didn't give you a lot of proofs. All right, if Mrs. Lenz was trying to get you to prove that this is an isosceles triangle, I would want you to know that you would have to show me that two distances are equal. Okay, and how you can show me distances are equal is with the distance formula. So mathematical proofs actually use numerical values to prove things. So if Mrs. Lenz wanted you to prove that this is a square, quite a bit of work to prove it's a square. Distance to show me all four sides are equal. Then you'd have to show me that these are right angles. So to prove a right angle, we've been using slope, and we show that the product of the slopes, slope 1 times slope 2, has to equal a -1 in order for that to be a 90-degree angle. Okay, if you have to prove anything with parallel, distance shows me nothing about being parallel, you guys have to use slope. Just to review slope, the formula for slope is y2 minus y1 over x2 minus x1. It is change in y over change in x. It is rise over run, or if it's negative, I like to think fall over run. Okay, what I want you to do is really just think about what you're trying to prove for me. Okay, I gave you about 10 problems, hoping like crazy to see you guys next week. Okay, all right, thanks, bye-bye.